Hello viewers, in this video we are going to talk about the heat map and correlogram. Correlogram is a type of a heat map that graphically shows the correlation between two variables. So let's start with the heat map. What is a heat map? A heat map is a two-dimensional data visualization technique that represents the magnitude of individual values within a dataset as a color. By observing how cell colors change across each axis, you can observe if there are any patterns in value for one or both variables. Now, here is an example of the heat map. This heat map shows the KPI, the key performance indicator of 4 different marketing teams. So on x-axis you can see the KPI metric against which the performance of each team is evaluated, and on the y-axis is a team name. And you can see the color intensity. The color intensity of each cell is based on the KPI score the team has received against each metric. Now for example, if you see the color intensity in a heat map, we can easily tell that the team B has performed well in metric 3. However, it requires a lot of improvement in metric 4. So this type of heat map is used by marketing executives to review the performance of marketing teams and rapidly identify the areas of improvement for each team against various KPI metric. This is how the heat map is used in exploratory data analysis to quickly find out the patterns in the data. Okay, so now we got the idea of how the heat map is used in the analysis. Now let's create the heat map. We will going to load the two packages, the tidyverse and the NYC flights 13. The data set that we are going to use in this video is flights data from NYC flights 13 package. This dataset is about on-time data for all the flights departed from 3 New York City airports. Now we are going to filter out few observations from this dataset. We will take a case of Delta Airlines and we will find out the arrival delay patterns of all its routes. And we will use the heat map to quickly visualize the delay patterns of all the Delta Airlines routes. Okay. Now here is the carrier code DL, stands for Delta Airlines, and we are going to use the same carrier code here for our filtering. So let's create a data frame called flights_DL, and let's use the filter function from the dply package to filter out the carrier DL. And we will also going to select few columns which are relevant for our analysis. So carrier, arrival delay, then origin, and then destination. Destination. Yeah, and then let's view this data set. Okay, perfect. So now we got the separate data set for Delta Airlines carrier, and now we are ready to plot the heat map. So let's draw the heat map now. Now in order to draw the heat map, we will use geom_tile geometric object. So let's start with ggplot function. Data will be flights_DL. Aesthetic layer on x-axis, we will use the origin. On y-axis, we will use the destination, flight's destination, and we will use the values of arrival delay to fill the heat map. So fill equal to arrival delay. So that becomes our aesthetic layer. Then we will use geom_tile as a geometric object to plot the heat map. Now here is the interesting part. we are going to use the color gradient here, and the color gradient will change based on the value of arrival delay. So we are going to use the black and white color scale. We will use this scale underscore fill gradient function. I'm sorry. Fill gradient. So this will decide the color scale. For the low values of arrival delay, we are going to use white color, and for high values of arrival delay, we are going to use black color. So the color gradient will change from white to black. White scale is for small delays, and dark black scale for large delays. That's what it means. And our final layer will be theme classic. That will give us the white background to our heat map. Fine, so let's execute this now. So you can observe that most of the flights are with minor delays. That's why they are shown in white color or the shades of white color. However, there are few flights which have inordinate delay. For example, have a look at this flight, which is from LG Airport to Pittsburgh International Terminal. And looking at this color gradient, we can say that this flight is almost delayed by 250 minutes, more than 250 minutes. So this kind of a quick delay analysis could only possible with the help of heat map. So extending our discussion on heat map, there is another version of heat map called Correlogram. Correlogram displays the correlation coefficient for all possible combinations of two variables in the dataset. Correlation coefficient is used to find out the relationship between two variables in the dataset. The coefficient varies from -1 to +1, indicating how strong a positive or negative relationship exists between variables. So if the correlation coefficient is -1, it is strongly negative relationship, and if it is +1, then it's strong positive relationship. So we are going to use the weather dataset from the invasive flight setting package. We are also going to use the flights dataset, and we will try to find out whether there is any correlation exists between arrival departure delay and various weather parameters. So let's transform the data first. I'm going to create a new data frame called flights_core, flights data. We're going to filter out again the Delta Airlines carrier. Remember the inner join. We will use the inner join function from the dplyr package because we want to join these two data sets together, the flights dataset and weather dataset. One thing to note here is that the correlation function does not work with the missing values, so we need to drop the missing values here. So we'll use the drop any function and view. So let's view our data frame. Right, so you can find out that it has lots of columns, lots of variables. So we'll have to select the variables which are of our interest. So let's do that in our next step. I'm sorry. So flights_core, flights underscore core, and we will use here select function to select arrival delay, departure delay, because this is what we want to understand if there is any correlation exist with delays and the weather parameters. And then starts with we will use, because we want to select all those columns that are starting with wind. So let me show you those. So all these columns, you can see that wind direction, wind speed and wind gust. We want to select all those columns. Then comes the temperature, then pressure, precipitation, pressure and visibility. Yeah. Okay, comma temperature, comma pressure, comma visibility. So let me check whether I have written that column names correctly. Pressure, visibility and temperature, temp, right, and view. Great. So let's execute. Oh, I missed the closing bracket here. So let's execute. Yeah, now we got the data set now, which we can use to plot the Correlogram. Great. Now we will create the correlation matrix. Now in order to create the correlation matrix, we will have to install the package called ggplot2. So I've already installed that package. We have to load the library ggplot2, and then we will have to find out the correlation between the variables in the data set. So we will have to find out the correlation amongst all these variables. That's what we are going to plot, right? So let's find out the correlation of all the variables from the data set using cor function. So I'm going to create a new data frame here, cor underscore matrix. Okay, so cor function flights underscore core. We're going to find out the correlation shape amongst all the variables in this data set, and I'm going to use the round function here, and I'm going to use the two-digit places for all the correlation values and view. So you can see that it's a correlation matrix that we got, and the value that you see in the cell is the correlation. In fact, it's a Pearson's correlation between the two variables. For example, 0.87 is the correlation between the wind gust and wind speeds, and 0.87, since it is closer to 1, you can see it's highly correlated. These two variables are highly correlated, right? So that's how you interpret the correlationship matrix. Okay, now we are ready to plot the Correlogram. Now in order to plot the Correlogram, we will use the ggplot function. So ggplot function, the first argument will be the data set. In this case, flights underscore core underscore matrix. It's basically the correlation matrix that we have created, and there are few arguments that you need to pass on to this function. The first argument is a method function, which is the visualization method of correlation matrix to be used. Now you can either visualize it by square, or you can visualize it by the circle. So we'll use square. Then the next argument will be the outline color. Now once you decide your visualization method, you need to also give the outline color. So what will be the outline color for the square? Now in this case we will use black color, and label equal to true is used when you want to display the correlation coefficients on the Correlogram. And once you use the label equal to true, then you need to also set up the size of the label. In this case we will use label size as 4, right? So let's see. Right, so this is the Correlogram, and one thing you can notice here is that the correlation matrix has all the same values above the diagonal and below the diagonal. So we can show only the lower or upper diagonal matrix as well. So instead of showing the entire matrix, we can also show either the upper or the lower diagonal matrix. So this can be possible if we set up the type argument in ggcorr function. So let's set up that argument here, comma type equal to, let's say, lower. So this will show only the lower diagonal matrix, right? Okay, and the values that you see inside is actually the correlation coefficients. Now we are interested in finding out for the Delta Airways, is there any relationship exist between the delays and the weather parameters? And looking at the correlation coefficients for departure delay and arrival delay, we can find out that there is hardly any relationship, as the correlation coefficients values are so small that we can say that there is hardly any relationship that exists. So all the delays, either departure delay or arrival delay, is attributed to some other factors, but not to the weather parameters, right? Fine. So let's summarize quickly. A heat map is a two-dimensional data visualization technique that represents the magnitude of individual values within a data set as a color. By observing how cell colors change across each axis, you can observe if there are any patterns in value for one or both variables. Heat map is created using geom_tile object. There is another version of heat map called Correlogram. Correlogram displays the correlation coefficient for all possible combinations of two variables in the dataset. We use ggplot2 package to plot the Correlogram. Remember, we calculated correlation between variables using corr function, and then pass these values as arguments to ggcorr_plot function to plot the Correlogram. So this is very important. You need to find out first the correlation coefficients between the variables, and then pass on these coefficients to the ggcorr_plot functions to plot the Correlogram. Each value on Correlogram denotes how strong the association is between two variables. We have come to the end of the video. Thank you very much for watching till end. If you have any comments, then you may leave your comments on the comment section. If you want to have the notifications for all the new videos that I post, you may also like to subscribe to this channel. Thank you very much. Thank you for watching. I will see you soon.